Hey, this is Jose from Mandoya Space, and today we are going to go through a tutorial about EUBrowser. EUBrowser is a powerful application we have online that provides several satellite images. It has all the satellite image from the Copernicus mission, so from the European Space Agency, which are free and are available, no problem. It is a fantastic tool also to use in the education. So we want to go through an example, and we are going to use this example to discover the basic features of EUBrowser. It's not going to be very advanced, but the idea is to try to solve a case, a problem, solving this problem, starting to learn about how EUBrowser works. And which is the case? The case is the following. We know that infrared radiation, this is in another of these YouTube videos, the infrared radiation contains a lot of information about the status of the vegetation. So then the idea is, let's try to use false color image, because the false color image contains infrared information to understand what is the status of the vegetation. And in the particular case, we are going to focus on the place where we live in Andoya, because we are very far north. We are living in 69 degrees latitude, which means that here the change between winter and summer goes very fast. And when we are interested to know how fast it goes, I mean, how fast the spring is just appearing, from having no life, let's say no vegetation, to be full of vegetation. So this is going to be the goal, to try to see with the data provided by these images how that goes. So yeah, this is our case, and for this we are going to use EUBrowser. So let's see with this tutorial how it goes. So there it is. We are going to start basically showing, yeah, how to find EUBrowser. And it's very simple if we just write in Google EUBrowser. So then, well, we have the first thing that appears is just what we need, is the user interface. This link over here is kind of great as well, because it contains a lot of information, further tutorials and things that are nice to explore afterwards. But we would like just to go directly to our user interface and try to learn how it goes. So we click there. So there starts to appear the user interface. So we do have a window in the middle, say welcome to EUBrowser. Yeah, that's something very nice. You should go to continue with this tutorial, especially the first time. Could be very nice to take a look, but we are going not to do it in this tutorial. But please, if you have time, just consider doing that. So we click, and this is going out. Let's take a look what we see. We see the global area where we see just the maps. And actually, the satellite image that are going to appear are related to these areas that we see here. So then, in addition, we see a window, a large window over here, which is the main window with the functionalities, with the possibility to select different kind of satellites. You see there are several satellites, not only the Copernicus missions that are all the Sentinels, but also satellites that can provide old images like the Landsat, and so on and so on. So this is very powerful and give you a lot of possibilities. Really, the professional can work with this as well, no problem. A lot of information is there. And then over there, we have a lot of buttons for different options. And we are not going to use those in this first tutorial, in this first approach, but afterward, in other tutorials, we will go through this. But maybe this could be convenient, because if we see in this mode, there is the normal mode, that is the one that we are looking, and the European Space Agency has prepared an educational mode that has not maybe so many possibilities, but it's just prepared for teaching. So it's simple, but it has what we really need. So if we click there, we see that this area here to the left is actually more simple now. What we can see, okay, we are in the discover main button, main area, that is where we start by default. So there are different themes. And what is a theme? Is where we want to concrete our search. The normal thing is monitoring Earth from space. And this is the general case scenario we are going to use. But in addition, if you want to just use a particular case related to agriculture, I mean, look, for example, agriculture features in one place. So maybe this is very convenient because the image that it will show, they're ready to show the best possibilities for agriculture, means the best possible bands, the best possible infrared information for displaying the agriculture. And in general, the same for something else, air pollution, we have geology, ocean, blah, blah. We have several things. And volcanoes, we will see also an example of volcanoes at the end. But what we'll do is start with the general case, monitoring Earth from space. Click there. So then we do have all the possibilities of data sources, which means the possibilities of satellites to obtain information. You just go down to one, which is Sentinel-2, which is very convenient. And then just make it simple. We just use this one. This is very good. We have a small question mark symbol, always that appear in several occasions, and that is extra information about what this is. So if we just click there, there is some extra information about the Sentinel-2, the goal of the satellite, and some extra information about the images themselves. So it's nice to read through this when we are not very sure about what we are selecting. So this is some things that we need to concrete afterwards. But the first thing is to select our area of interest. And this is to the other side, where they say the other side. We say go to place. Okay, so there we write our place. That is going to be Blake in Norway, which is in the north part of Andoya. So this is Andoya, and Blake is in the north. This is the one that we want to study. We have the possibility just with the hand tool, just to drag in the normal way, and just in this button in the lower area of the user interface, we can zoom in and zoom out. With the plus of zoom in, so we can just zoom in until it displays what we are interested. That more or less this can be okay. Yes. So this will be our area of interest. So from here, we want to download all the possible satellite image from one specific period of time. If you don't write nothing, it's going to download the latest satellite image from the latest 30 days. But we do want to see a case that happened in 2017. So we want to study how fast the spring came in 2017. So then we want to see first a case scenario, look for an image in June, around June. So we select in the period of time 2017, there it is, and then May. So we go from May to June, from May 16, for example. So there is from May 16 to June 16. So again, 2017. Now we go to June and we select 16 again. So this is already, so it means all the images in this period of time, this month, is from 16 of May to 16 of June. This is a place here, say advanced search. That is convenient to select. So to click there to activate it, because there is two possibilities, is which type of image. The L2A is convenient, so we don't need to do anything here, atmospherically corrected, that is great, that we like it. But this is a maximum cloud coverage. By default, it's getting all the images. What means independent if there is a lot of clouds or there is no cloud. But in the north, we have several days which is just full of clouds. So we are not interested to go through those images because we cannot use them. So we just go with a lower level of clouds. We are going to say to the program, I just want images that don't have more than 25%, 24% of clouds. So I just want those to be retrieved. So these are the conditions, this plus this period of time. So we just make search. So there it is, our search. And in our search, we can see already 2 possible images here. Another way, if you have several images, it's nice to click in the area you're interested, for example, here, and will appear exactly those that are displaying this area. Because sometimes here appear some that are not really focusing on those areas, but close. But if you just click on the top, then it will appear exactly those that will display this. And here we are interested in the, maybe this first one, 8th of June. So we visualize it, click here, and we visualize it. And there it is, and there we have our image. This is a real color image. The real color image means that it's the image as we see with our eye. It's a normal image. And here you see all the different possibilities to make a visualization of the images. Because the powerful thing that we have with this program, with EO browser, is it does not contain only the optical information, but also it contains all the infrared bands. But just by combining infrared bands with optical bands, we can also display another additional very important information, as we will see now afterwards. So, but let's say that we are interested in this image. So the first thing that we are going to do is to say, okay, I want this image. Yes, I'm interested. I want to save it. So for saving this image, so this will put the image in the pins. One thing that I'm going to do is to see if I have images in my gallery of pins before. By clicking here, I'm going to see if I have all pictures already selected from my previous time that I was making, using EO browser. I see that I have some of those. So I don't want this because I don't want to be confused with the experiment that we are doing right now. So I'm going to delete everything. So we are starting with nothing. So we're coming back to where we were before, not in pins, but in visualize. Usually you won't have at the beginning anything here. And just delete everything. And which means is that if now I pin the image, it will come here. So I click in this button, say add 2 pins. So I'm clicking there, and you see it coming again here. And now we only have 1 because I deleted the previous from my previous days. So I have only this one to save it here and to compare with another image afterwards. So we are coming back to this area where is visualization. That is the main area that is displaying all the possible type of visualizations. Therefore, we are okay. We are already happy. We have saved the real color image. But in addition, we have said there is this possibility. The vegetation, we know that reflect a lot of infrared image. By far, it reflects more near infrared image, energy than green energy. So therefore, it's more convenient to study a band in the near infrared because we will have more energy. And at the same time, there is more contrast between the different type of vegetation. So it's more convenient, the near infrared information, to understand better and more clearly the different type of vegetation and the status of the vegetation we are looking. And for this, we have the possibility here. This is the false color image. And the false color image is using the band 8, 4, and 3. The band 8 is the near infrared band. So this is one very good for the vegetation because there is a lot of energy going on there where we have fresh vegetation. And it will paint this infrared using the reddish color. So everything that is very red doesn't mean that it's red, but it means that it's reflecting a lot of infrared. The 4 band, which is the other one, is really in the reality. In the reality, will be a red color, but here it will appear like greenish. And the 3 is a green color in reality, but here it will appear as bluish. So everything is mixed somehow, but this is the only way to see where we do have a lot of infrared reflectivity. So we click there. And there we have, and we see that really is very reddish. Really is very reddish, which means that we do have a lot of vegetations everywhere. And if we see more in detail, we see several different kind of tonalities, very shiny reddish over here, some more opaque reddish at different tonalities here and there and in other places, which means that we do have different kind of vegetation and different status. So this is a great image to try to understand vegetation and what is going on. So we want to save it as well. So we want to pin it as well. So we go back to this button here and we add pins. There we go. And now we have 2 images, the one from before and this one. So let's think that we want to compare. We want to compare the real color image with the false color image. So here is the place. The place is called compare. So we just click in compare. And in principle, there is nothing. So say, okay, just please add all the pins. So then we can compare the pins that we have there. So it has had all these 2 pins that we have there. So here is like a layer over a layer. So on the top, we have the false color image, and below we have the real color image. So there is a way to compare to one is split, the first one. So if we just use and put here the hand, and we just move this, so you see that we are putting out the first image, which is the false color image, and then we see the real color image. And here it is again. So this is one possibility for comparison, and the other here is opacity. Again, here we can repeat the same, and it's just an opacity, it disappears in opacity, the layer in the top, and it appears the one in below. So there it is, and there it is. I prefer using a split, so I'm coming back to a split. And the first question, maybe just to take a look about the importance to complement information about the using infrared is, if we are coming here to the natural color, we see there is a lot of green areas, greenish, fresh vegetation already here, some vegetation that is coming already, some brownish area still, but already things going on. Here we have, and this, please take a look to this area here, very green area, seems to be fresh grass there. But let's take a look what is saying the infrared information, especially to this area. If we go on, we see that this area is not red at all. It has the same reflection in infrared that it has the water. We know that vegetation reflects a lot of infrared information. But for example, water does not reflect absolute nothing. Here means that we do not have reflection at all in infrared, which means that something that looks like green and that we were maybe confused that it was fresh grass is not alive. So it must be something else. So think about it. Think about what this can be. And this is just a very simple scenario to see how the infrared information can add more information. But I can tell you that the studies of the contrast that we can see here, and even if we see this not qualitative, but if we download this image and make an analysis a little more numerical, we do have further better information here to try to understand the different kind of vegetation and the status of vegetation by using this image, this near infrared channel. So yes, we go ahead And because the next thing that we want to do is to see, okay, there seems to be a lot of vegetation already, so spring is almost finished there. We are almost starting summer, right? But let's see what happened a little earlier, just a couple of weeks before that happened. So we go back, and the only thing that we are going to do is to change the time where we are going to download the image. For this, we go to Discover, and we say back to search. Same area, and in the same area, but we are just going to change the time. So for example, it's the 16th of May, I will say the 2nd of May, just some weeks before. And this maybe to the 13th of May again. So I have to put here May and the 13th. So just a couple of weeks earlier. Again, I say search. Again, click here. And I see that this is an image maybe too cloudy, but this seems to be very good. So I'm going to select this one, which is the 12th of May. Visualize it. There it is. Already we see that there is snow and very brownish here. So it seems that the vegetation still was somehow dead. But the best way to check it is in the near infrared. Here we see that still this area is very greenish. So we can give an idea already that what we see here is green grass, but not alive. So if we go to the false color image, we click it there again, and then we have this image where the reddish are very different, very different. So we try to compare this with the previous one. So again, I'm going to put it to add to the pins. So there are in the pins, and in the comparison, I want to compare all of them. The best way to compare all of them, if I say add all the pins, they will be repeat these two. So I remove in the comparison, I remove this, everything, and then I add again all the pins. So then we do have again only 3, and we are not going to repeat the same image a couple of times. So we're in pretty good shape. On the top, we have the false color image from May, earlier May. I think it was the 12th of May. Then we have the false color image of the 8th of June, just around 2 weeks, 3 weeks afterwards. And then this is the real color image of the same day. So if we just move this, so we see how the reddish tonalities are changing kind of dramatically for some areas, and also dramatically from other areas. So we do see that, for example, if we look to this area, the change is dramatic. All this area, they were here, they're completely dead because there is not a shiny red, but it's very brown, more yellowish. So there are more dead areas. This here, we do have already some fresh vegetation going on. And this here, there is not too much difference with the image, this current image that is in May to the one in June, which means that the spring here, the alive vegetation came a little earlier. So therefore, this is, of course, this is a different kind of vegetation. So again, we can take a look. And this is just an example of how comparing these images, we can get some outcomes about how fast in 3 weeks, how fast the spring was coming to our area. This is very important. We are trying to making a small project because comparing, this is coming every year like that, very fast. Just in a couple of weeks, we are going from almost no live vegetation to full of live vegetation. But because of the climate change, we are having some hypotheses that maybe this is shifting in time. So we are trying to analyze if everything is happening around how we see here, later May, first week in June, everything is done, or if this is some changes, and if those changes are related to maybe climate change. This is a possible very good case that we will use several of these cases using only this image in 2017, but the idea is to come from the earlier image, maybe from 2000, 2010, so on and so on, and making this comparison. So you see, from a very simple way to make an analysis, we can go to a very, let's say, interesting problem issue. So yep, and let's do a final thing, which is this nice image. We can download and we can use it in another external programs. We can download those images and use it, for example, in QGIS. We can use it in Google Earth Pro. So there are several possibilities, several different formats we can download the images. For download the image, we have to be registered. So all what I have done so far, we don't need to be registered. But for download the advanced image, we need to be registered. So at the beginning, you have a registration button. Just do it, because this is a really this is a European Space Agency tool, and it's very simple to register. And for education, the idea this is completely free, and so it's really very worth to do it, to be registered. So how to download the image? You see this button here to the right to say download image. So we just click there and open this new window. And the window has three possibilities: the basic, the analytical, and high resolution print. The basic, actually, you don't need to be registered to use the basic, but we want to use analytical. This only download the GPG images. But in analytical, you have more options. So for example, if you click and open this field of image format, you see here that we have KMZ, GPG, KMZ, PNG. Those are for Google Earth working very well. I mean, those are the format, Google Earth format. And those TIFF you can use for several other programs. So all the information is there, you can use for QGIS, for example. So it's very powerful, all the information, all the band, it is just there for making all the analysis that you want. So let's see that we want to download this format just to see in Google Earth with a medium resolution, which is okay, and the coordinate system by default, it is okay. So everything is ready, so just click in download. And there it is coming, our image already downloaded in our local computer. So I'm going to go to Google Earth. If you just go to the place where this image is and just click twice, so Google Earth program will open and will send you directly to the localization of this area. So I just did it, and there it is. You see that here is the area we are studying. You see that the resolution actually in Google Earth is by far much better. But the advantage of your browser or the Sentinel-2 is that we have all the spectra analysis. We have all the infrared information in this case. So in addition to this, automatically, when you click to the image, it will appear a new layer. And this new layer is exactly the image we have exported from EU browser. So this is very good because you can use in the classroom Google Earth as the tool afterwards as a main tool, and EU browser basically to produce, when it is needed, the infrared help, the infrared extra information for further analysis. So here it is, and now even if we zoom a little inside, so we see this area that was one of our main problems. So see that really was it's a football area, so it's a fake grass, artificial grass, what we do have there. So yep, so this is a little of how to use Google Earth combining with your browser. And the last thing I wanted to say, coming back to our EU browser, is other case that is using infrared information. I have it here already, and this already went to Santa Cruz de la Palma to the eruption that is going on there. And then I selected at the beginning the case of volcanoes. And when I select at the beginning the case of volcanoes, in the visualization mode, it came differently. It came these possibilities, because this is trying to set together information of infrared plus information of the optical in the best way to highlight your case. In this case, it's a volcano. And this is also working very nice, for example, to fire in the forest. So in my case, it's a volcano. So you see, this is the true color that always will be there, the true color image. Well, we don't see almost nothing because this is the volcano here, but it's just the ashes. And then there is a lot of fog and dust. So it's very difficult to see nothing there. But if we use this with this a combination of true color images plus infrared highlights, then the situation is very different. Because with this information, we can see something like that. We can penetrate with the infrared easily. We can penetrate in the ashes, in this smoke, no problem. And we can see by far much better the lava flow, how it is affecting the area that is affecting, and how it goes and how it behaves. So yeah, this is another case scenario. There are several. What I wanted basically is just to show another example, to show the good possibilities and the powerful possibilities that we have with EO browser, because we can add the infrared information to the normal optical images. So I hope this tutorial has helped a little to introduce you in EO browser and to make you curious to maybe go at least some step forward and to try to use it for another cases. So thank you very much. And yeah,